Yeah. We started PMIs. And in the PMIs, I think we only did the divisibility type of PMIs, right? So we were doing proofs, right? Proof by mathematical induction, right? And we did the one to divisibility only, right? Remember the main steps? We had to show it holds for n equal to 1. And then we had to assume right? Assume it holds for n equal to k. And then we had the main step, right? Show it holds for n equal to k plus 1, right? So we had those steps to run through and be able to work out the PMI, right? Right, everybody have those notes, right? Let's see if we could try a few now. So today now, I'm going to just give you one hard one with the divisibility, and then we go into this summation type, okay? I just want to give you one hard, I didn't give you a hard one last week. Did I give you a hard one last week? Rihanna, say all was hard. Rihanna, all could have never been hard. How much I gave you last week? 2 or 3? 2, and that was had to be real easy, yeah. No, I gave you 2, Nikolai. Okay, let's just do word body visibility and then let's try the summation, right? Remember your homework last week was to look at how to expand these things out, right? That was your homework from for last week, because I'm going to be using those things today. All right, so just try one quick divisibility schema. It's a little more challenging, right? Right, so I want you to prove by mathematical induction, right, that 3 to the 4n minus 1 is divisible by 16, right, for all values of n more than or equal to 1. Right, that should be a trickiest one there to try. Wow. Divisible by 16, right? Is that correct? Right, do the usual steps, right? How much is that again? That's 80, right? Which is 16 by how much? 5. Right, therefore divisible by 16. Right, go ahead, have fun to do the next part. I just write in this because this is usual steps I would take all the time, right? All right, go ahead, finish it out. All right, if you get it, just message. If you get it, just message QED. Anybody having trouble with the audio? You all hearing okay? Yeah. All right, I should be able to, for those who do in physics, I should be able to come back out by Friday, right? I damaged my Achilles, so I can't stand on it, and it's swollen, so I can't do anything until the swelling go down. So I just had to lie down here until I could go on crutches. Right, I know some of you all prefer the face-to-face, but now can't go to the game Wednesday. Not really this thing going on. Right, one QED pop up there. Have one QED so far. I waited to get 25 more. QED. 2 QEDs, nice. They coming in. 3. Nice. Keep sending out. Wow. Sending. All right, 2 minutes again. Right, oh, that's all I have. So I wasn't there last week. Very, very bad, Naisha. Very, very bad. All right, so you might struggle here, Naisha, but after the when I start the summation, it should be all right. Right, I'm still waiting on some more QEDs. I have 10 so far. Adrian, I get yours. Aiden, I get yours. All right, some more coming in there. All right, so while you're doing this, I will make 3 to the 4k the subject of the formula. Right? And now I have to show it holds. I have to show it holds for n equal to k plus 1. Okay? So I have to show it holds for n equal to k plus 1. How are we doing that now? So all I'm going to do is I'm going to write 3 to the 4. This is important. You put open brackets. K plus 1 minus 1 is equal to 16. You can change your letter to B. Right? So we're focusing on the left-hand side. So the left-hand side is 3 to the 4 by k plus 1 minus 1. Then multiply it out. You'll get 3 to the 4k plus 4. Right? Most people who get this wrong, they wrote 4k plus 1 instead of multiplying out the brackets properly. Right? And then just break this up. 3 to the 4k plus 3 to the 4. Hold on. I'm sorry. So this will be 3 to the 4 by 3 to the 4. Oh gosh. Hold on. Right? And let's finish it up. 3 to the 4 is 81. Right? By, is it 81, right? 81 by what? Where is 3 to the 4k? Right here. So I'm going to put that part in here. So that'll be 16a plus 1 minus 1. So that will be 81 by 16a. I don't have a calculator, right? Plus 81 minus 1. So that's 81 by 16a plus 80. Now I can factor out 16 and I will get 81a plus 5. Right? It don't really matter what the value is once you can do this. And you can say is of the form 16b. So you're good to go. Therefore, by mathematical induction, I did write out this step I gave it. It holds for n equal to 1, n equal to k, n equal to k plus 1. Therefore, it holds for all n more than equal to 1. All right. So we're going to apply this now to questions that instead of having divisibility, they have summation. All right. So before I do the actual PMIs, I just want to run through summation. You would have done this in AdMaths when you did APs and GPs. So it won't have a recorded class. Yeah. It's being recorded now. Look on the top left of your screen. Okay, anybody writing there? All right, so head up summation. right? So before I study PMI, I just want to explain summation, right? So if I told you the summation of R going from 1 to n of, let's just say R, right? All that means is that we summon all the terms of R. We summon all the terms of R until we reach n. So we summon 1, that's the first term for R, then 2, then 3, then 4, all the way until we reach n. Okay? So a small example, if I told you the summation of R going from 1 to 5 of 2 to the power of R, right? So you just summon all the terms until you reach R is 5. So the first term, R is 1, you add in that to second term, R is 2, third term, R is 3, R is 4, R is 5, right? That's basically the principle behind this summation, right? Right? What you're going to need now is you are going to need to be able to understand a few little things when you're doing the PMIs, right? One of them is this. If I were to add this, right? If I want to write that, that's the summation of R going from 1 to 4 of 2 to the power of R. Nikolai, you okay with that? And if I add that, if I add R going from 1 to 4 to 2 to the power of R to, if I add that to 2 to the power of 5, then this statement here, this whole statement here, right, is the same as the summation of R going from 1 to 5 of 2 to the R. So what you're going to see in PMIs is you are going to see the summation of this plus this term is called the K plus 1 term. That's the term right after this, right? That's the K plus 1 term. And this here is the summation of R going from 1 to K of whatever the function is. Let's call the function AR. So what you're going to learn in PMI is that whenever you add the summation of R going from 1 to K to the K plus 1 term, what you're going to get is the summation of R going from 1 to K plus 1 of e to the R. Right? So all I'm trying to say is that if you want to break up this notation, all you have to do is sum all the terms from R to K and add it to the K plus 1 term. So every time you see this plus this, you will get this, right? And you're seeing it here. If I were to sum the first 4 terms plus the last term, right, I'll get the sum of the first 5 terms. Okay, that's the main thing that you need to gather from this. Okay, so the main thing I want you to gather from this is that whenever you summon R going from 1 to K plus 1 of any function, let's call the function a to the R, right? Any function you want, right? Is the same as the summation of R going from 1 to K plus the K plus 1 term. The K plus 1 term is simply the last term, right? It's just simply the last term. So for example, if I wanted you to work to write this to me, let's say it's 2R plus 1. Let's say that's the function. How am I going to write that? Well, you're going to write it like this. The summation of R going from 1 to K, right, to K of 2R plus 1 plus the K plus 1 term, right? Because that's the rule that we're using, right? If we sum all the terms plus the K plus 1 term plus the last term, we'll get a total summation, right? So What is the k plus 1 term? The k plus 1 term, this is the last term, right? How do I get the last term? Real simple. Just take k plus 1 and put it in there. Just like how you put r as 1 and r as 2 and r as 3 and so on, all you're going to do is put k plus 1 in that formula, right? Wherever you have r. So it will be 2 by k plus 1 plus 1. Then you simplify that out. This is what you're going to need in PMIs. Okay? So whenever you sum those two, you get the sum of the k plus 1 term. Right? There are some other rules that we need to learn, right? But you will honestly, you won't use them right now, but you need to know the rules. If you were to sum r going from 1 to n of a to the r plus the summation of r going from 1 to n of b to the r is the same as you summing r going from 1 to n of a to the r plus b to the r. Same thing with minus, right? And next thing you could do is if you have the summation of a constant, the summation of a constant is simply the constant multiplied by the total number of terms. Okay? Right? What a rule you will need, you multiply, divide. And there's a next rule that I will show you later on, but these are the rules that we need for now. Okay? So this is the most important slide. For those who screenshot this one here. If you're writing, of course, write this one. So we're going to use this now in proving the summation type PMIs. If you want to be right, so I'm going to start with the most classical. Actually, I feel like I can handle it. I'm going hard one time. Right, I'm going to do the r squared. Now, let's do the r first. I'm going to do the r squared. Right, that's the most popular, one of the popular ones. Right, so this a little bit longer, a little bit longer. The hard step is the, well, being able to factorize properly. Anybody writing? Right, this is the most important rule here. This one. That's the one that we're going to use more of now, right? All right. Anybody writing still? Adrian, you writing still? Okay. All right, so let's give it a try. Wait, Shiv, is she? This boy not even there. Hold on, huh? Where is the line? All right, so let's go. So let us prove by mathematical induction, right? I'm doing one of the classic, you'll find this anywhere, right? that the summation of r squared, r going from 1 to n, we have to prove that is equal to 1/6 by n plus 1 by 2n plus 1. Right? 1/6 by n plus 1 by 2n plus 1. If it's the same PMI from, well, same, yeah, this summation here, basically. Easier than what you would have done as well. The ones that you would have done before would have been harder, but same process. Right, so same 3 steps. We're going to prove it holds for n equal to 1. We're going to make the assumption, then we're going to prove n equal to k plus 1, right? So let's start. So when n is equal to 1, we start with the left-hand side. The left-hand side is basically just one term, so that's 1 squared, which is 1. Then we go with the right-hand side. The right-hand side, we just plug in 1, right, into the formula. So that's 1/6 by 1 plus 1 by 2 by 1 plus 1. 3 by 2, that's 6 by 1/6, has also 1. So therefore, it holds for n equal to 1. Aisha, you okay so far? Okay. Next step, we're going to assume. So can you re-explain? Okay, well, all I did is I took n equal to 1, and I put n equal to 1 here, and I put n equal to 1 here. When I work it out, both of them gave me 1. So it working, so it holds. Right? So that's step 1. Step 1 is to show it holds for n equal to 1. Step 2 now, right? Assume it holds for n equal to k. So this is the assumption step. So all we're going to do is just wherever we have n, take off n and put k. So we're going to get the summation of r going from 1 to k, because I'm taking off the n, right? Of r squared is equal to 1/6 k by k plus 1 by 2k plus 1. Okay? And we're going to use this, right? We're going to use this later on. So I'm going to put a little star here, right? Because I'm going to use that in the proof in a little while, right? So assume it holds for n equal to k. Now, here's the tricky part. So we have to show it holds for n equal to k plus 1. Everything I write in here is just like a formality. It's just things that you're just writing and just change up the numbers. Nothing here should be difficult, right? So if you find that you're in trouble, tell me one time. I'm going to call it over, right? Everything here, you're just going to, when I change the question, all you're going to do is just change the numbers. Okay? So show it holds for n equal to k plus 1. All I'm going to do, take off the k, or take off n in the beginning and put k plus 1. So the summation of r going from 1 to k plus 1 of r squared is equal to 1/6. Instead of writing k, I'm going to put k plus 1. Instead of writing k plus 1, I'm going to write k plus 1 plus 1. And here I'm going to write 2. Notice I'm going to put my brackets because I don't want to make a mistake and simplify it wrong. So I'm ending up with 1/6 k plus 1, k plus 2, 2k plus 3. So the objective of this whole class now, sorry, not class, whole proof, oh gosh, what did I do there? Right, the objective of the whole proof now is to be able to prove this part here. Okay, so I'll just put in a little statement here. We're trying to prove, right? So I'm trying to prove that this left-hand side here is equal to this right-hand side here. right? That's the objective of everything now. So I'm going to write left-hand side, right? Summation of R going from 1 to K plus 1 of R squared. So I want to prove that. Okay, so I want to prove that. Good. Now we go back to what we did a little while ago, where we said that the summation of R going from 1 to K plus 1 is the same as the summation of R going from 1 to K of R squared plus K plus 1 term. Right, everybody remember this step here? Kalia, you all remember that step there? Nice. Ariane, Tavisha. Miss Halls, you remember this step? Okay, nice. Okay, so what do I do now? Now I am going to, let me write one more step before I make substitutions, right? I already know what the summation of R going from 1 to K is. See this here? That's the star. That's this star right here. So I'm going to write back that statement. I know what this is. That is equal to this. Okay. So I'm going to write that. I'm going to write 1/6 K, K plus 1, 2K plus 1. What is the K plus 1 term? The K plus 1 term is always going to be substituting K plus 1 for R in here. Whatever they give you there, just substitute K plus 1. And I'll get K plus 1 squared. Once you understand the principles of PMI, up until here is the easy part. After this is the hard part. We need to figure out how to make this fella here look like this fella here. We're trying to prove that. Okay, so let's see if we could do it, right? So the first thing I'm going to do, I'm going to just factorize, right? Because everything there is a whole set of products in the proof. So I'm going to factor out 1/6, and I'm going to factor out K plus 1. What would I be left with? I'll be left with K here and 2K plus 1, right? If I factor out 1/6 from 1, because remember, this is 1 by K plus 1 squared, right? Here what will happen? Instead of writing 1, I'm going to write 6 on 6. So if I factor out 1/6 from 6 on 6, I'll get 6. And if I factor K plus 1 from K plus 1 squared, I'll get K plus 1. Right? And that's the bracket part. Right? You see that fraction part that people make a lot of mistakes, right? If you factor out 1/6 from 1, you will get 6. Because 6 by 1/6 gives you back 1, right? And you'll be left with 6K plus 1. Multiply out inside here, you'll get 2K squared plus K plus 6K plus 6. You'll get 1/6K plus 1. You'll get a nice quadratic in here. 2K squared plus 7K plus 6. Right? We'll have to factorize that quadratic. And if you know you can't if you struggle with factorization a little bit, then multiply this out and you'll get this. Okay? That's the next option if you want. Right? If I factor out that, I'll get 2K K, and I will get I want to get 7, right? So I'm putting the 2 here and the 3 here. Plus, plus. And that's it. That's identical to what I have. So I could do my little box here. And then I could see, since it holds for n equal to 1, n equal to k, n equal to k plus 1, then by proof by mathematical induction, right? It holds for all n. I think this was more than 1, right? I didn't write it on top. More than or equal to 1. And that's it. It's not a difficult thing, but where it becomes challenging is right here. See that factorization to work out that? That's where the challenging part comes in. Some easier, some more challenging to factorize, right? Copy it down. I'll give you one easy one and then a few hard ones, right? Copy it down. Any questions? Naisha, since it's the first one, you okay with that? Yeah, all right. Stacey, any complaints there?
No, sir.
Not yet, all right. Copy it down. I'm gonna give you one to do, right? I'm gonna give you R, and then I'll give you a hard one. Oh. Okay, I can take it off. Can I take it off? Anybody writing? Okay, so I'm gonna give you one same procedure. I'm just going to give it for R instead of R squared, right? Take your time and see if you get this one. Either on your right pencil. Okay. All right, let me go. We got a little line here. Put a line down there. And after I get a line, I'm going to write prove by mathematical induction that the summation of R going from 1 to n of R is a half n by n plus 1. Right? For all, I think it's natural numbers or something. right? Most likely is all n more than or equal to 1. Go ahead, do your thing. Message PMI. I mean, message, what do you call that? QED, right? I see we could get 28 QEDs. I tried quick. Everybody, yeah? Safir, you too, huh? Where we at? I used to real message long time ago. Now I don't know what happened. No? I wonder why times change, Ariane. All right, go ahead. Do that fast one. Right. Any more queries? Hey, Rian, are you there? Are you there, girl? Yeah. Samira, nice. Who else we have there? Kalia, Nikolai. They're learning something online, right? Azaria, Amanda, Safir too. Not fishy, yeah. Safir, Kaylin, nice. Savisha. Look when Shavish now come into class, eh? Me say nothing, huh? Brittany, I get yours there. Brittany, Kevin, Ranju, Sarah Halls, what Genesis? And Genesis was here earlier. Emily, send something there. Emily, Venicia, nice. Kiran, good. I just doing the first few steps in the meantime, right? When n is 1, left hand side is 1 basically. Right hand side is a half of 1 by 1 plus 1. Half of 2, which is 1. Right? N equal to k. You're going to write the summation of r going from 1 to k of r is equal to half k by k plus 1. And then k plus 1 is where we're trying to prove this, right? So that'll be the summation of r going from 1 to k plus 1 of r is equal to 1/2 of k plus 1, and then take up n and you'll get k plus 1 plus 1, which is k plus 2. So usual thing, we're trying to prove this, and we are going to use this in our expansion, right? So you start with the left-hand side here. You have the summation of r going from 1 to k plus 1, right? That's the summation of r going from 1 to k plus the k plus 1, 2. Okay, r going from 1 to k, and then you add the k plus 1 term. So remember, you could take up this and write this. So that'll be 1/2 k plus 1, and then you add it to the k plus 1 term. K plus 1 term, just put k plus 1 wherever you have r in there, and you'll get k plus 1. Hurry up, finish up the rest. Remember what you're trying to prove, right? So fix it up. Let me see how much more QEDs we could get. Any more QEDs? Ramkistone, 9 yours. Sarah, I think yours. Stacy, you getting through there?
So I'm getting through about halfway.
All right, so where are you right here? Tell me what to do. What do you factor out?
I think it is multiplied out.
No, you're factoring out. What they both have in common?
K.
You sure? What you got? Both terms have what? Just like the last one.
Just now. So
Right, so
it is a half k plus 1.
right. And what should be left with? If you factor out a half k plus 1, you'll be left with k here. And if you factor out a half k plus 1, you'll be left with 2. You see that? And if you look at it, this is what you're trying to prove. So you have it. That was one line long. I don't know what you think, huh? You're okay with that? Yeah. All right. That's, oh, but by the way, write the line, right? Since it holds for n equal to 1 and so on, right? How you factor out the half? Right, because remember I told you, right? If you had a, remember it was a half k, k plus 1, k plus 1. Remember, k has 1, right? So instead of writing 1, put 2 on 2. So if you factor out a half from 2 on 2, you will end up with 2, right? That's how I got this 2 here. Okay? Yeah? Okay, let's go again. I want the easy, medium, or hard. A medium? All right. Okay, try this medium. Brianna, you jumped hard already. Let me go with medium first, Brianna. Let's go with medium. Right? Hold on. Some of these are past papers. Huh? Proved by mathematical induction that the summation of R going from 1 to n all right, I'm gonna give you a medium. 4R minus 3 is equal to n by 2n minus 1. Right? That's like a in between, there's like a slight in between medium and easy. N by 2n minus 1. I'm not giving you much time, right? There's like an 8-minute question, right? So you have 8 minutes. 4R minus 3 is equal to n by 2n minus 1. All right, let's go. Let's see what we got. I ain't got enough QEDs. I only have like 8, 9, 10. I need some mores. I need some mores of these, okay? So let's go with N is 1, left-hand side. All right, that'll be 4 by 1 minus 3. That giving you 1 again. Right-hand side, 1 by 1 minus 1. So that's what? 2 minus 1 is 1 by 1 is 1. All right, nice. So left hand, right hand, boom, bada bing, right? Have that. N equal to K, summation of R going from 1 to K, 4R minus 3. Remember, you're only taking off where you only replace N with K and not R. So you'll get K by 2K minus 1. Nikolai again, true? I see you send anything. Right? And then N equal to K plus 1. Somebody else ain't get nothing from far away. Emily and Ishmael. Send something, huh? Right? N equal to K plus 1. What do I do now? Right, good. That'll be the summation of R going from 1 to K plus 1 of 4R minus 3 is equal to K plus 1 by 2 by K plus 1 minus 1. Notice I have my brackets there. So I'll get 2K plus 2 minus 1. That'll be 2K plus 1. Right? It's important to multiply that out properly. So this is what I'm trying to get. So I'm starting with the left-hand side. Right? That's the summation of R going from 1 to K plus 1. Right? We know what this left-hand side is. Summation of R going from 1 to K of 4R minus 3 plus the K plus 1 term. Right? That's the same all the time. When I make my little substitution, right? I'm going to replace this with this, and I will get K by 2K minus 1. How do I get the K plus 1 term? How do I get the K plus 1 term? Right? To get the K plus 1 term, just take off R in here, right? So that'll be 4 by K plus 1 minus 3. So that'll be 2K squared minus K plus 4K plus 4 minus 3. So I just kind of multiply it out, right? So I'll get 2K squared minus K plus 4K is plus 3K plus 1. Right? When I reach here now, I will obviously, because of what I'm trying to prove here, I remember I'm trying to prove that there, right? I'll have some factorization to do. Again, if you can't factorize, expand this out and you will get that same thing there, right? So factorize it there and what we'll get. 2K, K, 1, 1, and addition sign. And that's it, QED. Right? And of course, write the last line since it holds 4. Right, copy it down. Any questions, all you? Some of y'all doing it. Emily, y'all doing it. Ishmael, Kevin, I ain't get any answers from all you. 90% out. Okay. Right. So the key is substituting properly and then factorizing, right? And if you find you're struggling with the factorization step and you're comfortable reaching here, then nothing wrong with expanding that. Once you could show both sides equal, you're good to go. Copy down. We gotta do one more. We've got to do one more. I didn't get plenty in this one. I'm gonna give you one with a fraction now. Let me see how factorize that. Right, the key is being able to factorize properly. Right, screenshot it quick. I want to go on to the next slide. All right, next one. I do have my past papers here. I wanted to give you one from there. All right, try this last one. All right, slight little fraction there. 1 over r by r plus 1 is equal to n over n plus 1. Right, try that, please. Right, we don't have much time, right? I given you 7 minutes for this one. 6 minutes. right? So keep working. I just trying to write out the first few steps, right? N is 1, left-hand side, 1 over 1 by 2 is equal to 1 over 2, right? Right-hand side, it'll be 1 over 2. So they're equal, right? Therefore, it holds. N equal to K. Summation of R going from N, sorry, K, there's a K on top there, right? R by R plus 1 is equal to K over K plus 1. All right. K over K plus 1. Now for N equal to K plus 1, that'll be the summation of R going from 1 to K plus 1. 1 over R by R plus 1. This will be now K plus 1 over K plus 2. Right? Again, I'll go with the left-hand side. Summation of R going from K plus 1. 1 over R by R plus 1. Right? Main thing here is that you get in you make the right substitutions. So you're going to substitute for this. And then the K plus 1 term. Right, so the summation here, that will be K over K plus 1. The K plus 1 term is putting K plus 1 in that fraction. So that will be K plus 1 by K plus 2. Right, so your denominators will look like that. K plus 1, K plus 2. Right, remember substituting here. I substitute for R here and R here. Now for the hard part. The hard part is to make it look like this. Okay? How do I make it look like that? Well, I have two fractions. Here I have one fraction. So obviously, I'll have to find a way to find the LCM. So the LCM is K plus 1 by K plus 2. How do I simplify that now? How do I expand that out? Well, you have a few options. Right. Yeah, so you have a few options, right? So when you multiply K plus 1, when you multiply by this, K plus 1 will cancel here, and you'll be left with, K by K plus 2. The next side, K plus 1 by K plus 2 will cancel, and you'll get the 1. So you have to finish it, factorize it up. K squared plus 2K plus 1 all over K plus 1, K plus 2. That is not it as yet. You still have more things to do. You have to factorize the numerator. K plus 1, K plus 1 all over K plus 1, K plus 2. This will cancel, and you'll get it. Okay? And again, what it boils down to, right? Being able to simplify this. Right? Being able to simplify that is the key. Okay, if somebody tried to factor out 1 on K plus 1, then you would have gotten K plus 1 on K plus 2. And then you have to find the LCM in here. And you'll end up with the same thing. Okay? So I want you to practice that, right? Practice this factorization and thing. Right? Any book you look in, you will see a whole set of these, right? Right? We have one more PMI to show you. It never came before. And then I'll give you some PMI questions to practice, right? With the answers. Okay, I will give you some other questions, but I have one more to show you. It never came, it never came before, sorry, but still you had to be able to do it, right? One is divisibility, one is summation, and the next is inequalities. So the last one is the inequality. It's probably the hardest of them. So next week we'll do a couple hard ones in summation from the past. We'll do a couple past papers. Past papers is kind of look like this. We'll do a couple from the past papers, and I'll do a inequality with you. All right, just one or two. I guess for you to have an idea of how it looks, right?